guys, and welcome back to my video. In this video we are going to be predicting Bitcoin prices using the LSTM neural network. So the first thing that we are going to do is we are going to import our dependencies. So we are going to import TensorFlow, Keras, and then we are going to import Plotly, which we are going to use to plot some graphs. So the first thing that we are going to do is we are going to provide the path to our dataset. So I have a CSV file. I have a CSV file with Bitcoin as compared to USD prices. So I'll put the link to this Kaggle kernel in the description below. So the first thing that we are going to do is we are going to load our dataset into our pandas data frame. So we are just going to name it data frame is equals to pd.readcsv. So here we imported pandas as pd. So we are going to say pd.readcsv using the read CSV method, and then we are going to provide the path as our variable. So the next, I'm sorry, I didn't run my dependencies. And then the next thing that we are going to do is we are going to print the total number of days present in our dataset, and also the total number of fields present in the dataset. As you can see, we have a total of 2,586 days, and the total fields in our datasets are 7. And then we are going to use the dataframe.shape to print out the shape of our dataset. And then we are going to use the head function from pandas to reveal the first 5 rows in our dataset. As you can see, these are the first 5 rows in our dataset. We have the date, the open, high, low, close, adjacent close, and the volume. And then we are going to print out the last 5 rows in our dataset using the tail function. As you can see, we have the date, open, high, low, close, and adjacent close, and then the volume. The next thing that we are going to do is we are going to print out the information of our data frame. As you can see, we have the date, which is a data type of an object. The open we have it's a float 64. The high it's a float 64. The low it's a float 64. The close it's a float 64. And then the adjacent close is a float 64. And then the volume, it's an int 64 data type. And then we are going to print out the description of our dataset. We have the count, we have the mean, standard deviation, the mean, and then we have the minimum, we have the 25th percentile, 5th percentile, 75th percentile, and then we have the maximum values in our dataset. So the next thing that we are going to do is we are going to check if there are any null values in our dataset. We do that by using the isNow function from pandas. As you can see, we don't have any null values, not available valuable. We also use dataframe.isNow.values, and then if there is any, and you can see we don't have any not available dataset. And then the next thing that we are going to do is we are going to verify that our dataset contains 7 years of data. So our dataset begins from 2015, 1 January 2015, 17 January 2015 to 14 February 2022, as you can see. And then the next thing that we are going to do is we are going to select our data frame by the date, and then we are going to convert our pandas data frame into to date time, and then we select the data frame, the date data frame, and then we are going to change it into the format of beginning with the year, month, and the day. And then what we are going to do is we are going to select the data set in the year 2015. So to do that, we are going to provide year 2015 is equals to dataframe.log. Dataframe will provide the date. We want a date that is greater than or equal to 1 January 2015, and then a date which is less than 1 January 2015. So the range is from 1 January 2015 to 31 December 2015. And then the next thing that we are going to do is we are going to drop our adjacent clause and our volume. As you can see, we now have the date, the opening, the high, low, and the close. And as you can see, our date now begins with the year, month, and then the date. And then the next thing that we are going to do is we are going to look at our data set month-wise, by month. So month-wise is close to 20. We are going to provide our 2015 data frame. We are going to group it by the date, and then we are going to select the opening, the mean of the opening and the closing price. And then the next thing that we are going to do, we are going to create a new list of order from January up to December. And then month-wise is equals to, we are going to month-wise, and then we are going to re-index it to change it, and then we provide the new order list. And that's our order list that begins from January up to December. As you can see, now we have the opening and close from January up to December. And then the next thing that we are going to do is we are going to compare the opening and closing price for the year 2015 monthly. So to do that, we are going to say our figure that we are going to plot is equals to go.figure. Our figure.addTrace, we are going to use a bar chart. And then our x variable, we are going to provide the monthwise.index. The monthwise.index, we are going to provide the monthwise.index. And then our y variable, we are going to provide the opening price. That is the stock open price. And then our marker color, we are going to use crimson. So same goes for the closing price. We are going to, the x variable, we are going to use the monthwise.index. And then the y, we are going to use the we are going to use the closing price, and then the name, stock price, close price. And then if we print out, you can see that now we have a monthwise comparison between the stock open and the close price. So this is the monthwise comparison between the Bitcoin opening and the closing price. As you can see, in January, Bitcoin opened at around $231, and then it closed around $231. So there wasn't much of a difference. And as you can see, in December also it opened at around $422, and then it closed at around $424. So now we are also going to compare monthwise comparison of the Bitcoin price depending on the highest value, or the highest value of the month, and then the lowest value of the month. As you can see, monthwise high and low stock price. As you can see, the highest price that Bitcoin reached in January 2015 was $309. The lowest price was $194. In February, the highest price it reached was $264. The low price it reached was $212. In November, the highest price it reached was $495, and then the lowest price was $300. In December, the highest price was $469, and then the closing price was $349. So now next thing that we are going to do is we are going to plot the line graphs for the stock open price, stock close price, stock high price, and the stock low price. So we are going to say the fig is equals to px.line. We provide our 2015 data frame. Our x value is going to be our date, and then our y value is going to be the open price, close price, high, and the low price. So as you can see, sorry, let me just run the volcano. As you can see, now we have the stock high price, which is green, stock close price, which is red, and then we have stock open price, which is blue. As you can see, these are the graphs. Now we are going to analyze the year 2016. So we are going to say we are going to select from January, the 1st of January 2016 to 31 December 2016, right? As you can see, now we have the values. So the next thing that we are going to do is We are also going to check the month-wise comparison between the open price and the close price. As you can see, in January 2016, Bitcoin opened at $412. It closed at $410. In December, it opened at $821, and then it closed slightly higher at $821. And then the next thing is we are going to compare the month-wise high and low price of Bitcoin. As you can see, in January 2016, it opened at $462, and then it closed at $354. In December, it opened at $879, and then it closed at $746. And then we are going also to plot also the same lines, the line graphs for the stock for the open price, close price, highest price, and the lowest price. We are going also to do the same for the year 2017. As you can see, this is the month-wise comparison between the stock between open and close price in 2017. As you can see, in January 2017, Bitcoin opened at around $914, closed at around $914. In December, it closed at around $15,000, and it's also closed around the same region. As you can see, also we can also the highest and the low price. As you can see, in January it opened at around 1,191. That was the highest price, and then the lowest was 755. In December, the highest was 20,000, and then the lowest was 9,000. The same goes for the line graphs. So we are also going to do the same for the year 2018, 2019, 2021, and 2022. So now that we have analyzed from the year 2015 to 2021, we are going to take a look at the overall analysis. So the overall analysis, we are going to start from 17 October 2014 up to 24 August 2022. As you can see the overall analysis, you can see that in 2016 Bitcoin was just ranging in the same price, but in 2018 it spiked up to 20k, and then it dropped to the lowest 3,000 in 2019, and then it went to 13,000 in 2020, and then by the end of 2020 we can see that it closed it closed at around 5,000, and then 2021 it spiked to the highest, which was 67,000, and then as we enter 2022 we can see that it's still at around 35,000. So now that we are going to be taking, so now for us to train our model, as you can see, from 2015 up to around 2019 Bitcoin was just ranging in the same price. But from 2020, we can see that when Bitcoin started moving, it started ranging or trending upwards. So we are going to train our model using the data set from a date which is later than 28 October 2020, as you can see. And then we can see the line graphs. We can October 2020 up to January 2022. That's the data set that we are going to use. And then the next thing that we are going to do is data normalization. As you can see, the close date is we are going to use the close date, and then we are going to normalize our data set using the min max scalar. We are going to normalize it between the range of 0 and 1. And then the next thing that we are going to do, we are going to split our data set into training and test set. As you can see, we are going to split it into a training and test set. And then the next thing that we are going to do is we are going to create a data set, which is going to take in a data set and then a timestamp. So our timestamp in this scenario, we're going to use a timestamp of 15, and then our X train and Y train, we are going to create the data set, and then we provide the train data and then the timestamp, which is 15, and then the X test and the Y test. As you can see, the training set, this is the training set, and then the test set that we are passing in. And then we are going to print out the shapes of our data set. We have 3, 0, 9, 15 by 1. And then the next thing that we are going to do, we are going to initialize our keras model by saying model is equals to sequential. And then we are going to say model.add LSTM. We are going to use an LSTM neural network. So an LSTM neural network is a sequence model used for events that happen in sequence, such as the stock market, natural language processing. We are going to provide 10 units of LSTMs. Our input shape is going to be none and then 1. We are going to use an activation of ReLU. And then we are going to add one more dense layer to our neural network. We are going to compile our neural network, and then we are going to use the loss function of mean squared error. And then we are going to use the Adam optimizer. The next thing that we are going to do is we are going to fit our training set and then our validation set. We are going to train our model for 200 epochs. We are going to provide our data set into batches of 32, and then the verbose is going to be 1. So now our model is training. We can see it's going to run for 200 epochs. Now the next thing that we are going to do is we are going to visualize our training loss and validation loss. As you can see, when we started, the validation loss was high, also the training loss was high. But after 200 epochs, you can see that it was almost close to 0. And then we are going to do some predictions and then check the performance of our trained LSTM model, as you can see. And then as you can see, this is our test predicted close price, and then our trend predicted close price. As you can see, our test predicted close price almost matches the actual price, showing that our model is performing well, and it's predicting the Bitcoin price almost very accurately. And then we are going to see the output for the next 30 days. And then as you can see the output for the next 30 days, as you can see, these are the first 20 days. The next 30 days, our model is predicting that Bitcoin might reach 45,000 USD. And then we are going to plot the whole closing stock price with prediction, as you can see. So guys, this was all for me about predicting stock prices using Bitcoin. If you have enjoyed the video, make sure you click the like button and the subscribe button.